How about now? There it goes. Welcome to Coffee Compiler Club. Here today to talk about compilers and language runtime and coding in general. I am going to give a talk about best practice, scare quotes, best practices um, that I'm going to give in a more public forum in another week or so. And so I was just looking for feedback. We're going to find out here, right? Hey, Matt. I'm going to let Levo, you had your question. And we're gonna
Yeah.
go. Oh, we're recorded live. We'll show up on YouTube in a couple hours, and everyone's all heard this spiel a dozen times before. Done. Okay, go, Lifo.
Okay. So once upon a time, I was measuring hash maps, and I noticed that when I was using an int identity as like the hash, it was inserting at whatever milliseconds, and then when I hashed it properly, it was slower, but not because of the hashing, but because the cache misses were much higher. It was extremely random. And I was wondering if, like, I didn't bother trying to optimize it because I'm not sure when I'm gonna need bulk inserting. But I was like wondering if like I should have like maybe eight arrays and then just like insert into the array, and then once it fills up, I just bulk insert that array and
Yeah.
then
So
repeat
so
until each gets full or until it's complete.
right.
I
So
have
so
no idea if that will work.
you're coming at this sort of the wrong mindset. You're coming at this from the mindset. Hey, Mark, you're coming at the mindset of I have this problem in my face. I want to solve it. And the right mindset is what is the long-term benefit I'll gain and how much time I'm going to burn to gain what kind of benefit. So if the problem is insert a bazillion things into a hash table, there are certainly ways to optimize that, including take your existing data structure, declare it a hash table, and walk away with zero clock cycles. Um, there are perhaps you have another use for this data structure, like you're going to look up things in the hash table. And then is it faster or more important to be doing more lookups versus inserts? Um, Hash tables are probably 90% of the planet. They are um, insert rare read many. And then there's some fraction of hash tables which are uh, write continuously and look up rare. Not very many, but they totally there's a use case for those. And then there's things in the middle, and it kind of depends. Are you going to be concurrent or single threaded? Are you going to be, how many things are you going to insert in this table on average in general? There are certainly plenty of hash tables in the Java community. I don't know if this happens in C as much, where the hash table over its lifetime typically holds zero or one and never more than that. And what the fuck did you use a hash table for? And why did you just have a null pointer versus a thing, right? So what is the total use of the data structure? What are you trying to accomplish here? And then we could go down the path of what is the right data structure for your larger problem you're trying to solve. And then the immediate question is, hey, I want to insert all the keywords in my language into my string hash table of all the symbols. I expect to do this insert once at the beginning, but then I'm going to follow it up by a million reads in the table according to however many lines of code I'm compiling or whatever. So the right answer for you depends on your use case here. So, okay, so now it's your turn. What's your use case?
Okay, so I know my use case, but I'm pretty sure it's so insignificant that it's not even worth the bother. But I was just curious
Okay.
because it sounds like a fun problem.
Okay.
So my
Ah,
use case is in my compiler. What I do is each source file, I have a small hash map that every time I see a new variable, I insert into it. But that's not my concern. My concern is once I'm done parsing the source file, I need variables. I need like an integer representation of each variable that's globally accessible. So I have a big hash table that I insert everything into. So basically, I go through each smaller hash table and insert it into the bigger one. Now, my mistake was I didn't measure it that way. I measured what happens if I just read a text file and try to bulk insert that way. So I don't know if it's already solved because I have smaller hash tables. And but I was just like curious in general because I don't know, like when I saw how much slower it got just because the hashing was really good,
no.
I think it was twice as slow or twice as long. So it was just
This
surprising.
This is all a case of measure your real problem first before you start hacking.
Yeah,
Or you're
yeah,
hacking for fun and just acknowledge upfront, I'm hacking for fun here. And people do fun
yeah.
hacking all the time. That's good.
I think probably the solution is just to use those smaller hash maps because that's what I need for my situation
It, it,
anyway, and
yeah,
I can't really think
you're
of
the guy
really.
who likes to make big giant data structures that don't resize, but hash tables definitely land in the category of things that are better if they are resizable. Because it's often the case that they're tiny and you just make them just barely big enough to hold the data, and that's the fastest thing you'll ever do. And it all fits nicely in your O1 cache and it's whatever. But occasionally they get big and you don't want to deal. So there's some one clock cycle check on every operation that says time to grow the hash table. And then rarely you grow the hash table, and then you never think about hash tables again.
Actually,
They're
another
just
thing
utility.
I, I overlooked was should I even be using the smaller hash tables for on our per source file? Because I figure that I won't have to deal with memory contention if I have
Yeah, yeah, you have single threaded or multi-threaded or whatever. I
yeah.
claim measure. If you're really interested, measure first. That'll change what you optimize for. If instead it's, I already know I need to do something here, then you do. And single threaded per whatever is fine. Concurrent hash map or non-blocking hash map are plenty fast as a general purpose hash table, and they don't care about, I mean, they're all concurrent free, whatever. It doesn't cost you anything. Well, non-blocking hash map costs you nothing to run it concurrently. Concurrent hash map will have more issues if you're writing concurrently. It's performance if you're writing concurrently. But
I
generally, if
often
you're
see
writing
hash tables
concurrently,
include an option to give an initial size if you want.
that won't help concurrent hash map if you're doing lots of writes.
It still does. It only
Does it?
current hash map only locks if you land in the same bucket.
Yes, if you can spread your buckets out enough. It's like,
Right. So if you set your capacity high enough, you probably
no, I think you have to set the striping factor high enough. You get 16 locks.
no. They use they
They changed
use
it.
the first entry in the bucket as the bucket lock.
Okay. Oh, okay. So they did change it. Okay. Back in the day when I was comparing against non-blocking, they had they had,
Yeah, 664 or whatever.
16. No, they had 16 in Azul systems, we would set it to 64, and some giant x86s wanted it bigger. But
That changes as you get more cores.
right.
I could have
Ben,
sworn that you had a non-blocking hash map that didn't need any locks and it was just all atomics.
right, that's what mine does. And I know there are people who've copied it in the land of C, so there's C versions floating around. So
I've
wait,
been
Ben,
I've been
what's
reading non-blocking hash map and wanting to talk about it for the last couple of weeks. So I'm so glad we're talking about it today.
Uh-oh, I have to do this talk. Now I have a quorum because I'm giving it in a week and I want feedback. I want, hate mail, throw Rotten Tomatoes. So let me answer Ben's and then we do my talk. And then we can talk non-blocking hash map and you can ask me what the
That
hell
can
am I
always be
doing
next
here?
week.
Yeah, at some point I'd like to hear Mark's feedback.
Just
Okay.
I
just
thought
on
I
the
found a
small
bug, but it turns out Cliff was just creative.
I
But I still think I found another bug.
There have
But
been so many people who thought they had bugs, and a lot of them have turned into this hole in the spec, which says you could go left or right. And I went
in fact,
left and somebody else
for
went
the thing
right.
that I think is a bug now, I'm sure that it is perfectly correct because you know how hotspot works. It is probably I don't believe it's correct to the language standard
Oh, really?
or
Okay. Well, now
specification.
we have to have a
But
discussion
I could be
now.
wrong, but we'll save it for when we save it.
All right. All right. All right. I'm going to go find my slides and do the thing. And this is a short talk, so it won't take that long. And I'm totally looking for feedback. And why the hell are you hiding things again from me? God. Here, maybe. Okay. My windows are not appearing. So for me, everyone can see my screen except me. That's not very helpful if I'm trying to read my slides. Shrinking all my windows. How about here? Geez. Okay, can you guys see the slide here? It's just a performance anti-patterns.
Yeah, I can
Yep.
see it.
Oh, my whole screen.
Yeah, you're sharing
You share
everything.
the whole screen.
Geez, stop. That was not the intent. Oh, I hit the
I had a boss that did that once and logged into Fidelity. That was fun.
Right. I clicked the just doing LibreOffice and it gave me the whole screen. Let me try
Yeah, if
again.
you start speaker view, it will often give you a new window, and then you can pick that window.
I don't know what speaker view is. Oh, it's done a presenter layout. It's trying to automatically go to I'm presenting. Okay, I claim this is just LibreOffice now, right?
Yeah, yeah.
Oh,
Yeah.
jeez.
Yes, we see the editor window, not the presenter window.
Oh my God. Okay. Thanks for nothing, Zoom. I'll have to remember that. So I type
Oh,
my
start
Oh, we
presenting.
can see it fine, so.
But hit the slideshow button and you should be good.
Yeah, I wasn't trying to because I want to be able to edit if people have comments.
Oh,
Mhm.
then we're good.
Okay, fine. So this is like performance anti-patterns, and in other code bases, but Hashgraph as well. I find lots and lots of these, and a lot of them fly counter to scare quotes best practices. So as the quick aside that I'm sure everyone has heard me say here, has had me say before, I predate all best practices by decades. I have been coding furiously and long before anyone ever came up with best practices, and I mostly find them bullshit. A stumbling block thrown up by those who can't to slow down those that can. I think that's really, really very pessimistic, very sour, but that's how it comes across to me all the time. I look at these people who say, do this, do that, and invariably it's just like, you are just wasting your time and mine. What the hell are you doing here? So I ask you to look with a critical eye as to what you've been taught versus what you've experienced. And most of these, here, let me go find this window. Thank you. Most of these best practices, but not all, are both, I claim, slow. That's the anti-pattern, performance anti-pattern, but they're also not helpful in terms of coding and velocity and making shit work. And now Google, there it goes. So the big loser here is allocation for performance. This is specific to Hashgraph's implementation. It's actually quite common in large Java programs. Very specifically, I'm not talking about large C++ programs. I'll get to that in a second. So allocation here is either free or incredibly expensive. It seems to be fairly bimodal. And when I say incredibly expensive, I mean like getting rid of it can be integer factor speedups, like large speedups. And that's because your system is either out of bandwidth or it's not. And single core programs have trouble running a modern system out of bandwidth. So I'm giving a benchmark that's internal to Hashgraph, but a lot of single-threaded benchmarks just don't run you out of bandwidth, which means your allocations are cheap. But if you have more cores that are busy allocating, you can totally run out of memory bandwidth, and adding more cores will give you this diminishing returns behavior. And so when I talk about allocation costs, I'm not talking about direct GC costs. Even when you're out of bandwidth, your direct GC costs might be really low. You can have furiously repeating young gen allocations of low milliseconds or high micros and be out of memory bandwidth. And I'm not talking about the bulk quarter allocation. That's one clock cycle pretty much always. So, what the hell am I talking about? Each time you do a new in a garbage collected language, you get a chunk of fresh memory. And this is not the case for malloc and free languages, so I'm only talking about things that are garbage collected. So Java, but any garbage collected language. And that fresh memory you get has not been seen by the CPU since the last GC cycle, which makes it a hard cache miss. And while you have bandwidth, you can prefetch, which will cover your latency. But when you run out of bandwidth, when too many people are prefetching, you don't have enough cycles to memory, the prefetch won't get it in time. You'll pay that cost to memory to go get to touch that new fresh memory you got. And when all the cores are allocating, they are all increase each other's memory costs. And yes, it compounds. And that's why adding more cores gives you this inverse reciprocal curve where it asymptotically runs towards some peak performance line that'll be gated by your bandwidth, right? It's typically hard to diagnose, or at least the people I talk to in the Java world typically have trouble recognizing what's going on. Your normal profiles will be flat. They're smeared out, warm everywhere. That's the canonical death throw that says, I can't make this go any faster. This is the limit. Your GCs will be fast. There'll be a lot of them, and they'll be fast. And that's because you're allocating objects which are dying young. So the tells here are GC logs reporting very high allocation rates. And you can do the math on the allocation rate on the GC logs and see that you're getting within 10% to 50% of theoretical peak maximum memory bandwidth. That tells you you're out of memory bandwidth for sort of everyday production use. And that's why you're stalling, and that's where your time goes, right? The other one to get is your hardware counters reporting front installs. Like he can't get memory back. It takes him so long to get memory cycles back into the CPU that the front end runs out of things to do, despite the fact he's got 100 out of order register, execution things all running in parallel. He still runs out of things to do, and you start seeing front installs. And the other tell is you add more cores to your problem, and you don't get a whole lot of gain, and you're not lock bound or IO bound, both of which are very easy to check for. So what else are you bound by? Well, maybe you're bound by memory bandwidth.
Oh, since you want feedback,
Yeah,
I've always wondered how to actually monitor this in Java because you don't have access to the hardware counters,
right?
In Java, but you're saying you can guesstimate it by looking at something from GC throughput.
The first cut for me is to say you added more cores, it didn't help. You subtracted cores, and it didn't give you much back.
I can tell that I'm not scaling.
Yeah,
right?
You're not scaling. Okay,
there could be so many reasons for that, right? How do I pin it on?
You have this smeared out profile, and maybe that's your application. It's smeared out, but commonly you have hot places in profiles, and you're pretty damn smeared. Okay, then I start looking at GC logs, and I look for young gens happening at a very high rate. And then I just do the math on the young gens and say, wow, I'm getting X young gens a second. Each one's reporting me so many gigs a second. Oh, look, I'm recovering 50 gigs a second out of young gen allocation. So it's some insane count like that. You do the math on the local hardware. He says, I have 100 gigs a second. That's probably not right. 200, 500 gigs a second maximum bandwidth. I'm running at 10% to 50% of max theoretical peak. Fall off a cliff speeds. Okay.
It seems I should also be able to monitor this outside of the JVM, right? There should be a tool that shows me this. Right?
Well, that's the hardware perf counters, right?
Right. But what is it? Intel vTune?
vTune.
Show this. Okay.
Yeah. I mean, they try hard for Java, but you need system level numbers.
Right. Yeah, that's what I'm saying is it doesn't have to do anything with the language, right? Because it's just my hardware is out of memory bandwidth. So if I look, I should be able to find a monitor for that.
Right.
Yeah, I would include in the slide a quick mention of what are the tools you use to find that. And you said in a one-off comment, and you're not having luck contention. I would put that at the very top and be like, hey, I'm talking about memory as the bandwidth, but here's some things you should check before this talk.
Okay. Well, here
first check that you're not in extreme luck contention. That's just part of hitting the scope that is this talk is.
Yeah, I think most developers aren't going to be. They're going to be stuck on lock contention before they get to this.
Right. So I would just put a slide at the top that's like, here are some prerequisites. You've already solved these. Yeah,
I'm going to. Okay, that's a good point here. Okay.
It only needs one slide of here are bigger problems that you should have solved first. But
yeah.
And should work with Java for what it's worth.
Say that again, Matt. It's the sound issue.
Perf should work with Java. Linux perf tools.
God damn it. Throw it in chat that your sound is particularly bad today, and it might be my fault, not yours.
He's talking about Linux perf.
Oh, perf. Yeah, you pull htop or xtop or whatever, you can go look in these two, lockbound and IO bound, show up on the standard perf meters instantly.
Is that any better?
Yes.
Maybe.
You're just, in addition to your bad mic, you're in a large echoey room.
And you talk a little fast sometimes.
Yeah, I have 2 instances of you in the Zoom as well, and I'm loath to kill one.
Part of it.
Oh, that's the laptop. Yeah.
That sounds better.
At least, one of the mats is muted, so.
Okay. All right, so did I cover what people just said here? I wasn't going to do a whole slide on things you do for performance checking. I'm just coming around to you're over allocating, and then I'm going to go down best practices of why are you over allocating?
I just think I think you're wrong here. I think this is what you, Cliff, run into because you do all the other things right. I don't think for most developers, I doubt they get to the point that this is the thing that's actually holding them back.
Let me go to that slide.
No, I've experienced this many, many, many times, especially with link queries and things like that, where people just do .to list. We'll convert it from this array structure to that array structure. You run your profile, and the and the profiler says, yeah, no, you just everything runs equally, not a problem. And you just go through and you just start eliminating all of the copying, and yeah, you get 10 times the performance speed. Yeah,
Right.
not even 10 times. I've seen one go from 20 minutes to 1.5 seconds just by eliminating copying. But the profiler said, no, you just
Yeah.
your time spent evenly across the application.
Right. Yeah. That's
No
that's the
hotspots.
normal profiles are flat, and yet there's this
Yes,
huge performance gain. All right,
that's how you spot it.
Yes. Okay. So
Okay, let's continue.
your next spotting thing from Ben here is you're spotting by you remove some allocations and things got faster. And that would be another tell here. That's a harder tell because you have to do some work first.
But can you do the inverse? Can you add allocations and see that it didn't make a difference, and then know that
You
that's
can add, yeah, actually, no, that is entirely fair. You have to be careful. You have to add memory bandwidth. So you add an allocation that you then touch. Make it bigger,
Certainly sounds more
That'd be
automatable in
harder.
a tool than the first one.
Yeah, and in fact, Bill Pugh has this great technique where he says, I have this messy application. I don't know where the hotspots is, but I'll add in slowdowns in all these random places and see what actually slows. And then
yeah.
I'll claim this spot matters and that spot doesn't. And he'll sort of profile you in the reverse by adding slowdowns. So this would be the same thing.
And it's so much
Ooh,
easier to make code worse than better.
No,
are we
I
talking about
really like the idea of a tool that randomly adds garbage allocations
Yeah.
in random places to try and build a map of your code and say, here are the places of your abstract syntax tree where it
Allocation.
matters.
So what I didn't go here is that allocation profiling totally works. You whip up an allocation profiler, he'll tell you you're making a bazillion X's. And you do the math on the bazillion and you say, well, it's a byte array, but the average is a K and I'm making a million a second. Maybe that's a gig a second. Maybe that matters, right? So you do some work to like not do that allocation. And oh, it speeds up hugely. That's a tell, if you will, that you're on the right track. But that's one that requires work, like upfront. Like tells for me are things you do upfront. Once I decided about memory bandwidth, the next thing I'll do is I'll allocation profile and go tackle the big things. But let me get into why what is a performance anti-pattern that goes along with this problem, as opposed to how you recognize allocations bad, which, Ben's like, I've seen this 1,000 times. Yes, I've seen it 1,000 times too. And then how you fix it. Oh, okay.
wait, where's this presentation? Can I
I'm
see?
going to give this to internal Hashgraph company meeting in a week and a half.
Oh, so
And
no.
this is
no-
it has no Hashgraph secrets here. So this is public. I'm obviously filming for YouTube. It's going to be public. I put a PDF
Will you
link.
share it? Yeah.
Put a PDF link in the Discord. I can put a PDF link in the chat.
I don't know how this is going to show up in the profiler, but the other day I read that somebody had like 70% of the CPU time because in one of his loops, like a large loop had a stream read. So it was like n squared. So I don't know how that shows up in the profiler, but that might be
So
interesting.
n squared things typically show up as CPU bound. They can be a memory bandwidth thing in a string concatenation loop where you concatenate a string and then bigger and bigger and bigger and bigger. And so he copies a little string and copies a bigger string and copies a bigger and bigger and bigger. That's an allocation. But if you do CPU profiling, you'll be stuck in that loop. And
If
so
I
it'll
remember
show up as CPU profiling.
if I remember correctly, the guy was like looping through. He was like building. I think he was getting hours of something, and he was building a map. And instead of just doing one pass, he had in a loop and then did a stream. And
Well, okay, let's claim there are a million ways to do things badly. And let me roll on because I want to see people's opinions about the other things for anti-patterns I'm talking about. But I think we pretty much agree here that allocation is a big one, and we need to deal with that and be
Yeah.
aware of it and see if that shows at the top of your profile.
I
And
mean,
Mark's
that's
going to
kind
tell me that my locking is not a thing, or I've given up too easily on locking. I'll get there in a second. I have a slide on that, but it's lame. But
It sounded like it was like building a lot, doing a lot of allocations in that. So I just can't tell how it's going to show up. But that's all I wanted to say.
Yeah, yeah, yeah. So this slide is okay. This is how the out of memory bandwidth burns out your CPU here. So the allocation brings in a new cache line because it's never been seen since the last GC cycle. And that burns some bandwidth to bring the memory in. Now, the memory that comes in is dirty from memory, and the CPU wipes it out. So you didn't need to do that bandwidth, bring it in. As far as I know, only Azul's cache line 0 actually avoided the memory read to let you zero line in your cache. However that's done, you lost some bandwidth coming in, you get some zeros in your cache. To get that cache line, you had to evict a line. The eviction is semi-random. The CPU tries hard, but you're striding through memory, so each new allocation gets a new slot in your L1 cache. You're wrapping it continuously. So your LRU gets stomped out and you lose out, throwing out almost surely a good thing, which becomes a cache miss later. Then you use the object, like you'd expect. And your generational assumption is working. The object dies young. Younggen will collect it. But long before Younggen collects it, the CPU notices the cache line is no longer being used. It got filled with real data. It got read out as real data, and then it's not used anymore. It's dead. So he throws the line out, which means he writes the dead data back out to memory, burning bandwidth again. So the effect is your caches are continuously flushed. There's a streaming writes through the caches that are wiping out line by line by line. And all the good stuff goes out with the bad, and you get a lot more cache misses. And because you don't have the pipe to memory is full, between the CPU and the memory is full, that pipe, you have to wait longer to get data to fill in all those new misses. So you have more misses, and they're all slower to solve.
If honestly, I would say, like, in my opinion, okay, I think it's very rare for most algorithms to bottleneck on memory bandwidth. Like, they certainly have this like latency effect on the cache line stuff, and that can mostly be alleviated with like SMT.
Okay, hang on, Ryan. This isn't a problem with typically an algorithm. This is a problem with an application. The application, the large million lines of code, is running around doing things, typically allocating when it doesn't need to, until it runs out of memory bandwidth for allocating. It's not typically some tiny algorithm that's doing some intelligent fucking bubble sort or hash table linked list chasing or something. It's not a stupid algorithm or smart algorithm. It's not an algorithm. It's the whole allocation, the whole application.
I assume this is threaded program.
And then they're usually servers doing multi-threading. So each thread is replicating the work. And Ben saying, there's a lot of optimizations for algorithms. Like, I want to do a matrix multiply, and I have to touch memory in these bad ways. And you tile the memory, and you get better memory usage, and suddenly get these giant speedups. And tiling's been well understood for 20 years. But it only applies to matrix multiply, for instance. So big allocations having an issue here. So big application is having issues, and that's what I'm trying to solve for. So this talk is me talking about performance antipatterns. The first one up is we're over allocating. We don't recognize we're over allocating. What do we do about it? And now I'm going to go into slides of talking about performance antipatterns, and many of them will say, and I did an allocation here and I shouldn't have, or don't do it.
How often do you see this? Because like from the benchmarks that I've looked at, like, okay, so let's
let's back up. As you just said it already. From the benchmarks I look at, okay, you looked at a benchmark. I look at applications in production settings, and I see this all the time. If I look at benchmarks, I don't see it.
So I guess here's my question, right? If you take a CPU with twice as much memory bandwidth, like a Threadripper 7980X, which has double the memory bandwidth of like a Ryzen, whatever, do you actually see double the performance, or are they bottlenecking on memory latency rather than memory bandwidth? Because I feel like those are two very different things.
Yeah.
And in almost all cases, it's latency and not bandwidth that is the bottleneck from my experience.
Okay, so I don't ever get to have the apples to oranges comparison where I take two different machines with double the bandwidth to run. That's never been an option.
But you could take out a RAM stick in a dual channel system as well, just to see if the performance
never an option. Go into the Amazon cloud server and reset up my application on a new machine, go into the machine and room and hack things. No, never been an option. Not saying it couldn't be done, just saying it's not an option. And these numbers can be seen from hardware performance counters. which will tell you that you're out of bandwidth. The hardware guys will tell you that. The hardware counter will tell you you're out of bandwidth. So the other thing I wanted to cover here is the machines. God damn it! I had a much more important point to make, and we ran off down the side path, and now it's gone. It'll come back around. Yeah, Mark's smiling at me. I know exactly what's going on here.
Yeah, it's like maybe you should do the presentation without us commenting once.
Yeah, and take all the comments at the end. The problem with taking all the comments at the end is people just forget them. So
we can throw them into chat and then you can look at them later or something, right? Because we're screwing up your flow.
It's true, and I kind of asked for it to be screwed up in order to, it'll help me later. Okay, let me proceed a little bit. We'll get back in the flow here. So we're talking applications, not algorithms. The fix, of course, is don't allocate, which obviously doesn't work. You got to allocate some. So instead of think about your allocations, can I avoid this? And the big one here is just you're allocating once per X, where X is big, large count, and that's expensive. So in Hashcap's case here, allocating a kilobyte for opcode executed, and you're trying to execute 1 million opcodes a second. So you're allocating a gigabyte a second on every core, and pretty soon that adds up a lot. Oh, that's what I was going to say for Ryan. Latency versus bandwidth. Prefetching turns bandwidth into reduced latency. If you have enough bandwidth, prefetching will let you cover more latency. But if you have a longer latency to memory and you got more bandwidth, as that was your trade-off, you needed that bandwidth to be prefetched in order to get the latency back down. Yeah, ultimately, of course, everything's latency. The prefetching is just turning bandwidth into latency.
Yeah, the forward point is really good at being prefetched, because if you're in a tight loop and you're just pushing the pointer forward, your CPU just goes, oh, I'll just prefetch the entire thing, and just destroys your cache because it's going to fetch just everything into cache just to be zero.
It does mean that linear scan algorithms are typically really fast because the prefetching works on them. Whereas like a randomized linked list, like a dirty linked list, is typically not prefetchable, and there's already I had a whole other talk on that one. All right, what can I do about allocations here? Builder patterns. Allocate to allocate just doubles the cost. Don't do it. Can you intern common objects? In my case, there are plenty of places where I can intern. Your mileage may vary. There are tricks to intern without allocating during the interning process. So pay attention about allocating during interning as a way you're trying to avoid allocation. If you allocate while you're trying to intern to avoid allocation, you didn't actually avoid the allocation, right? So you have to avoid the allocation while interning, and there's some tricks to doing that. Optional in the land of Java versus nullable. Optional is an allocation. Nullable works great. Why the hell aren't you using null objects? Shared immutable is always good because it's immutable and shared, so less allocations. Fine. More loser patterns here. Interface calls. Interface calls are cheap in isolation and expensive in bulk. And how does that work? Well, if there's exactly one implementation on an interface, the JIT will know it and cache to the concrete type, make it a static call, and maybe even inline. Life goes on. But if there's multiple implementations, but in practice only one hits a call site, get an inline cache. That's about a clock cycle to test you got the correct type, and then a clock for the call, and you didn't inline. But you did get one call cycle. But if you had two or more at a call site, you fail the one entry inline cache. And then as soon as you fail the one entry inline cache, you fall back to a linear scan to find all the targets. And the linear scan ends up using shared memory for the final jump, and the hardware predictor can't tell what it's predicting, which call path it's predicting for. So as soon as you have some significant count of these, the hardware predictor begins to fail reliably as well, and now you have 20 to 30 clocks for the unpredicted, mispredictable branch, plus the dozen clocks to do the lookup to linear scan. And you'll start with this happy path, one inline cache working, and some customer will ask for a weird off case. Some website, you're doing a web server, will ask for a weird off site. And that call site goes megamorphic, has multiple targets, and suddenly gets slow, and it remains slow forevermore until the JVM reboots and you rejit the code. Yeah, Mark says if you have two or more targets, but one is common enough. So up to a point, will the JIT will inline caches manually in the code for one hot case. He'll do profiling and say you've got a really hot case, so he'll
But
check for it.
the periodic wrong one will completely screw it up, right?
It not okay. So in back in the day, the periodic wrong one totally screwed you up. Some time ago, before I left Sun, but not. I guess that's been a while now. I'm trying to remember if it ever happened for interfaces. For virtual calls, we totally went to the case of profile. There's a 90% case. I'll just put that case JITted directly in the code. If 90% case, inline code, else virtual call to slow path. I don't know if that ever worked for interfaces.
And yeah, actually, I shouldn't have said in the context of interfaces. I was just talking in general with the caching the common case, and I was thinking of I did something recently, so this is like not 10 years ago. It's like 2 weeks ago.
Okay.
Where I had a like very very common case, and then but it was still megamorphic. I had like 4 other variants it could go to, and so I instance subbed on the common case and let the other 3 suffer with having to go the full megamorphic route.
Yeah, so you did the histogramming in your head, the profiling in your head, and said, "I'm writing the code to say here's the hot case." And like I said, for 2, we directly did it for NIO and direct byte buffers versus heat byte buffers. So in the JITted code, so the inline cache is always 1 because that's how the structure of how that works. The JITted code will go to 2, and he'll say if hot 1, else if hot 2, else horrible. And then you get inline things with an if check in the middle, and that's not super good because you have a hot loop, and in the middle it says if this, 1, else if this, 2, else bad. And the bad might actually jump out of the loop and not poison it, but the loop has an if of 2 or 3 bad things. And you'd rather have the check done before the loop and then have 2 clones of the loop body if unswitching. Right. And that wasn't going well when I left. I had just thought about doing that when I left before it got done.
So if I'm trying to choose between inheritance and composition, where I either have one class with a helper object or 5 different classes, but everything's right there, does this give advice?
You should have the same problem.
You have one object main and a helper with the helper has 5 choices, or you have 5 big objects. Is that what I just heard?
I can sort of push the place where I have my fan out higher or lower.
Yeah.
And does that matter?
I claim yes. What really matters is where you go megamorphic and can you reduce that at the hot places or do the loop and switching or whatever. That's typically easier to massage the code into a more efficient shape if you have reduced the megamorphic to some small piece of, and here it gets weird. Here's my static shit that's the same for everybody, and here it got weird. Now, to go efficient, I might say, I'm going to flip these out and say, the outer loop has the known, and this guy has his known, and this guy has this known, but that's like an algorithmic change as opposed to a data structure layout change. I claim you want your data structures to be well understandable, and if you can contain the wildness to this one little spot, and here I have an object with this bizarre shit, you're going to be easier to optimize down the road. Okay, I'm going to read through chat real quick here. Yes, hard to tell if a site goes megamorphic on you. Yes. What really happens in these big applications is that they really are megamorphic. They're just, as Mark says, there's a happy path, and then there's a rare off path. And the rare off path screws up all the optimizations. And you manually talk about that one. Ryan saying something about link time optimizations. This is all done in the realm of Java, where you have perfect closed world knowledge at all times. You can keep loading code, but he knows now the new improved larger closed world, and so he optimizes based on that, which would look like a link time optimization if you're coming from a C world. And the difference between, switching from branches or indirect calls, whatever, that gets into, I have an inline cache as a design decision because I can write one efficiently and cheaply. But if I'm jitting and you've added a new class and it changes the profiles, the rejit should pick it up. No builder objects. So string builder is a case that's actually makes sense, Levo. Stop making strings has been, I use string builders all the time, but I reuse the same string builder usually. I build my string and then I reset the string builder and go again. And so I'm not making new objects.
I would have
The
said
reason
that
string
slightly more
builders,
generically of a mutable object builder makes sense.
yes.
I have a mutable thing that builds up all of the fields and then spits out the immutable object.
And then you reset and reuse it. That's what's not going
I would call
on.
that a factory, not a builder.
Yes. Oh yeah, right. Okay. That's probably a good term to use. All right, I think we're done with interfaces. The only weird trick people don't get that I see for other folks don't understand is the cheap in isolation, expensive in bulk. When you overwhelm at one call site, the one call site got expensive. When you overwhelm at hundreds of call sites, the hardware quits predicting as well. And all of your call sites now that are running the megamorphic call also take the hard mispredict jump. And then they didn't inline as well. And so you have a ton of calls, and the calls take the most expensive route, and suddenly it's expensive. This really hammers people like who use a JVM with a different alternative call model, like Groovy or JRuby or Jython, and they have a billion interfaces, and suddenly every call site they do is both not inline and does the most expensive possible call. Yeah, not really happens outside of there, but in big applications, I see a lot of interfaces that are used excessively that turn into expensive interface calls. And here's the pushback I get from people who say, "Hey, I want my interface," and that's flexibility, and that's ease of adding a new thing. That's code velocity. And then my pushback to the pushback is performance is also business critical need here. It's not always. In my case, I have some regions of the code where it clearly is, and some regions where it's clearly not. And where it is, I have some triad. I don't explain well there in the middle. I have the triad problem where I have flexibility or ease of code velocity. I have ease of use to implement the thing, and I have speed and picking two. So I can make you fast and flexible. You can change your cost model. You can change your gas model for your smart contracts. You can change whatever other things, but I have to work that knowledge through the JIT to get speed. Or I'm using this interface and it's really easy to add new things out, but the speed suffers, right? And you can pick any two out of those three.
Would introducing the instance of check inside the interface inside the code would help in order to
if
push
you know that you have, this is what Mark's just said. If you know
Mm.
what you have is a highly, I would say bimodal distribution, you have a hot guy and you know the hot guy, you can explicitly force the inlining. If X instance of hot dude, the common guy, normal call to X, where I've lifted its type from an unknown to the specific dude. And then the JIT will choose to inline. He has a static call and he'll inline or not. He'll do the right things. And then you say else, if it's not the instance of, oh God, it's the bad thing. But the bad thing's rare. Else, make the call again. But now the JIT will choose a different thing on those two different paths.
Yeah, would it help instead relying on the JIT to discover those cases which are hot?
That's the limitation of what the JIT is willing and able to do. When does he know? How does he know? And does he get it right? If you have two guys, he'll definitely profile left and right and start to think about that. If you have three or four guys, he won't. He'll cap out. He has a histogram. The histogram has room for like three things. There's some small count he has, and as soon as you have more than that, he'll pick the one guy who got there early enough to be in the top guys. He'll get the max of the early guys, which you can prove there is a test case where you won't get the max guy. Right? There's a finite histogram. I have to have some fixed amount of space for every opcode that I'm doing profiling on. Here comes a class. The histogram's empty. Oh, I'll say, put the class in, and ding, gets a count. Here comes another guy. Ding, gets a count. Gets a count. Gets a count. Okay, here's the fifth guy. I only have 4 slots. I got to throw one out. I throw out the least counter. Put this guy in. Ding, gets a count. This guy gets a count. That gets a count. He gets a count. The hot guy now shows up after the 10th go around. Comes in there, gets a count. One of the other guys, one of the 3 others shows up, tosses out the hot guy, and they go back in. And you swap the hot guy in with other people, and he never catches a hook and gets counted up. That can happen. You have to have very specific patterns to make it happen. It's much more likely you'll get the hot guy, but you may not get the second and third hot guys right. And as soon as you get more than a couple, it's almost never a win to actually say if hot, else if, second hot, else if, third hot, else if, fourth hot, that's a quick route to losing. But you might know more than the JIT does specifically here and say, both this is hot and it's hot enough that it's definitely 90% or more. I want it to inline and everyone else can just suffer. Then you split it out manually by saying if instance of the hot dude, else everyone else. And the two arms could just make the same function call, but one will get profiled immediately as the hot guy, and the JIT will do the right thing for the one guy, and the other guy will land in whatever bucket he lands in. If he should be a instance of chain, if he should be a maxed out virtual call, if he's an interface doing the linear scan, but he'll just do whatever that makes sense.
Okay. On your back and forth argument with people on interfaces, the thing that I've argued before is there's nothing wrong with them. Use them, but don't be cutesy, right? Like in a method, don't return two different versions of an iterator, right? Like if I always return you the same iterator, we're probably going to be fine, even though we're using the iterator interface. But there's places where it's like, ooh, I'm going to return you the empty iterator if I don't have any contents. And now you've completely hosed the place that uses that iterator.
Yeah, that happens a lot here in Hashmap. Yes. Yeah. There is a wrapper around a byte array that they're trying to say we're going to share like a string builder. You would have offset and length. And they're not copy on write. It's just the same buffer and I have an offset and a length. And I hand it back. But I have a different class for the 0 length buffer and a class for the 32 byte length buffer and a class for the generic one. Now I have 3. All those interface calls all fail the slow pathway.
Yep. Right. And if they limited themselves to 2, they'd be okay.
Right. You'd be better off. That's correct. You can hit a 0, just give a length of 0. I don't fucking care what your array base is. Give your length to 0 and walk away. And done. Fine.
Clojure definitely does that. Their core object data structure has a class that is the empty version of it, and a class that is the less than 32 things in there that store them in an array, because you can iterate an array very quickly, faster than you can do the dictionary lookup.
Which company is doing this? Which project?
Clojure.
Clojure. Yeah, right.
The JavaScript, the Java Lisp.
Yeah, I know what Clojure is. Yeah, okay.
But they very much, you type bracket, and what you get depends on how many objects are in there.
Right.
1 to 32 is a
special
different
case
class.
A bunch. You're right. Yeah, a lot of those things are well down the path of diminishing returns because they blow out all of the hot path inlining things. Let me go answer some things in the chat here. Ben says cache pressure sounds like compilers inlining the 8 options. It'll blow out your iCache. Yes, it will. Yeah, absolutely, Ben. The reason I don't inline the 8 options is because you get iCache blowout. And if you manually inline, because you said if instance of X, else whatever, then that iCache blowout's on you, but particularly you probably know better. And if you generically just went to every call site and said, this guy has such and such frequency, I'm going to inline the top X patterns. I've totally been down that path. That's a knob. You can turn in hotspot. We fiddled the knob. The answer is you blow out iCache. So it's cut way the hell back. But it's a knob. You can turn the knob. Or 20 years ago, you could turn the knob. I think a lot of knobs got exposed under the XX flags, and you can shoot yourself in the foot in a lot of ways. Let's see here. Brian saying no strings. Oh, this is Java, man. Strings are everywhere. And a lot of folks do strings. There's protobuf to JSON to blah, blah, blah conversions that are not yet
the top
free file. Yes,
strings
exactly.
are slow. Don't use strings unless you are processing
they're
text
getting
data.
there. Life is convenient with strings and slow. And so now can you change your mind about the strings? All right, we're getting there. Yeah, a lot of the things I'm doing now, I'm profiling, I'm doing the right thing. I'm profiling first and hitting the right buttons first. But a lot of things that happen here convert byte arrays to hex strings and back. They are not yet to the top of the pile, but they will get there before long. You are 100% correct. Yeah, Ryan saying, hey, single indirect function call or 3 branches is roughly that's roughly the right breakdown. That's roughly the breakdown I make. If X, else if Y, else indirect branch, you get 3 options. And more than that, definitely runs into diminishing returns. Leave a few code with strings, and you will be probably coding with strings in your future. You'll be thinking about it. Strings
You
are
only
terribly
need them
convenient.
if you want people to use your software.
Yeah, the strings are terribly convenient, but they can turn into the bottleneck. And I have been on projects, not this one, where the strings were the bottleneck, and we interned correctly, and that rescued them hugely with a stupid one idea. Right, dot intern, you make new things. There are a couple of things, a couple of tricks you do, and suddenly they got their not 10x speed, they had a 10x reduction in their latency and a huge reduction in their SLA. Their SLA went from 95% to 99.99% when they got to interning strings properly. Fine.
I
Okay.
remember optimizing a switch for strings when it was very heavy because I didn't want to do a string compare.
Yeah.
But I know in other functions in C, the string is just a global static variable that's constant, and I could just do a compare and not think about it.
Yeah.
So I was wondering if I could always not think about it, except for the
No.
rare case where I have a hot loop in a switch.
No. So in the land of Java, most of your strings are not interned unless you're making them. And many strings get constructed from pieces parts, so they're not in a constant static pool. And the string compare, you don't have a pointer comparison directly in the land of Java at all. The nearest sort of moral equivalent is you can look at hash codes, which are consistent across strings. Same string could be the string hash code, but you might have 2, 10, 100 copies of the same string in the heap, and the garbage collector keeps them all separate, and their pointers move around according to whatever GC does. So you're not taking any pointers off of strings. If you know that you've interned, you totally can turn it into a pointer equal equal check. And I totally have some of my compiler hack things. I intern everything, including strings, and then I do a string equal equal string, not a dot equals. And then every IDE complains at me that I'm not using dot equals. And I have to tell it, no, quit that. These are all
I
interned.
just cast it to object and then it doesn't complain.
Oh, I went into the damn thing and added this fucking comment annotation that says, don't complain. Fine. Cast to object. Excellent. Okay. What else we got here? Optional. Yeah, okay. Horrible layout on the slide. I don't like optional. It's a clarity hit for me as well as performance. And yes, it's an allocation and C allocation cost we just discussed. Um, hey, pushback, escape analysis. No, that's been promised a long time, but escape analysis is a hard problem in general. It's hard enough that Rust makes it the entire reason to entry to have zero cost optionals, right? You have to work really hard. And in the case of Rust, it's a whole other language with a whole complete new kind of analysis and required annotations to get those optionals to actually disappear from the allocation. And then they optimize down to a null pointer under the hood, right? But null pointer is just so very cheap to run. It's optimized to the nth degree by both the JIT compiler and the hardware. You're just never going to beat it for performance. And in my opinion, null is cheap to look at. Some languages do better than Java, say Kotlin. Actually, C does a little bit better because you can do pointer null checks with just directly hacking on the pointer instead of doing pointer equal null.
The point of optional though is to avoid the badness that happens when you forget to do that.
So in Rust to C++, or Rust, to my understanding, also does the same way C++ does. It's not a pointer, and there's no allocation. It's just a bool in a storage location, like as a struct.
Right. But to get there, they had to optimize it down, and they got that by having you say, and the lifetime of this thing is such, and we got it to disappear away to being not allocated.
No. Even in C++, like without the borrow check or any of that analysis, it's just like it's a bool, and then the storage, it's like a non-optional object plus a bool.
Okay, I'm confused. I'm talking null pointers on null or pointer. The pointer itself is a standard pointer of however many bytes your pointer size it is, or all the bits are 0 in it. There's no.
So that's not what we call an optional in C++, but okay.
Oh, okay. Well, I'm talking now optional in C++. There, I don't know what optional does for C++.
Yeah, that's different.
Yeah. Then you fall into the C++ rules for memory lifetime management. And they have some places where that's really nice, and some places where you blow it up and you have memory allocation. You have memory lifetime breakingness. That's the reason you went to Java, because it was garbage collecting. You didn't have memory lifetime analysis problems. You didn't double free your optional. You didn't fail to free it and then leaked it and then ran out of memory because you leaked to death. Right? There's the good reasons for having garbage collected language, and there are bad reasons. But one of them is, hey, I didn't care. I just allocated, and then actually you cared.
I want to give you two other.
Yeah, go ahead.
I wanted to give you two other notes on optional, and then I unfortunately have to drop. So the general best practice with optional is that you only use it for return types, which is like, I hate optional, but if you're going to use it, that's the only place that it's even should be an option.
Way more overused than my current.
It's horrific for everything else. Yes. The other thing about optional, right? When you talk about the like escape analysis and stuff, people will tell you it goes away with Valhalla. And the answer is it does not. They were not able to for 32, if you have compressed pointers, it could go away. But if you're using more than 30 gigs of RAM, you're stuck. Like optional is still an allocation, even with Valhalla. So, and on that, I gotta go. This is a cool presentation. I'll probably watch the recording.
I'll definitely bring up. I mean, we were definitely running these on machines with 256 or half a terabyte of RAM. They're more than 32. Yep. Bye.
Bye, guys.
Bye, Mark. So as a defense, I would like to say that optionals pretty ease the work with collections. So
I find it not. I hear you say that. I have used collections that could only, like Elm has, like, you can't be null in the collection, and that just sucked to use. Or I don't know, there were a bunch of things I could or could not do with collections and optional that just did not make any sense to me, that were always more heavyweight in the coding and the clarity versus just fucking checking for null.
I don't know. I think Java took the route Scala does with an optional, which represents when it's time to work with the collections, the optional represents an empty collection, and it's easy to go over it, all of the stuff that doesn't have values. That's one easiest.
Yeah, I'm confused why you say it's a clarity hit.
Because there's extra parens. This gets into slides coming up, where I'm drowning in a sea of function calls, most of which are junk. They're getters and setters. And I want to know where the performance goes, where the complexity of the system goes. And having a function call where I didn't need one adds complexity. So my little example at the bottom is exactly this case. oPointer.map is a complexity, is a mystery function call, is a question. What the hell is it doing? And he takes a lambda on top of that. Maybe it all boils away to a null pointer check. I don't care. I find that harder to read than the code right above it, which just explicitly checks for null and then makes the call or not. And the result is null, not an optional of an empty, but a null, or the result. I find the top one just hugely easy to read. Now, if I go to Kotlin or I go to simple or C, then this top guy actually gets a lot shorter, and I just this. And I find this even easier, and Java, in my opinion, Java should have gone there. But the whole, I had a function call, and because that's the only syntax you have for adding this kind of thing. So you have function calls, and then suddenly I'm looking at thousands and thousands of which 90% are junk. They do something stupid simple, but memorize of the thousands which of the 90% are junk and which are important. And that's the hard problem. I can't get to the meat of the issue without sorting through the billion opacities of a mystery function call. I'll get there in a minute. Okay, Ben says, compiler should complete compile away optional. Yes, it should, and it cannot, because it requires escape analysis, Ben. That's the issue. Yeah. Rust demands the user participate in the escape analysis logic, and therefore gets the borrow checker to discover that, in fact, it's useless. And
most of the problems with optionals is the representation, not with the idea. So
for me, it's the visual presentation. I would rather have the more clear, I have a null pointer or I don't. And then there's a performance hit as well, that the object doesn't get optimized away.
Yeah. Okay. Cool.
Okay. And then Matt says, reading from chat again, Rust has a bunch of niche optimizations. Well, Java had niche optimizations that were niche at the time because C didn't have these problems, and Java did. But now I guess they're not niche anymore.
Optimization is a specific term specifically for things like enums and options.
Yeah.
You can have zero cost storage for the option. So even if you nest it with other types, like you can have a variant type in Rust, it's called enum, and in that type you can have another type, and then you can have another type which nests the option, and that option is not going to cost you because Rust compiler may be able to see that there are bits that are unused in the data structure, and it's going to use those unused bits to basically store, quote unquote, the value of the option. So that's called niche optimization in Rust compiler.
Yeah.
It's pretty cool, actually.
I think, yes, I've seen these things before. I think it's really cool. And Java didn't go there. And I think Rust did a good job with that. And, some future date, I'd love to go play more with them. These are things that I saw this in Zig a lot too. Smurging all the enum error codes together and then just using unique bits for missing none of the above or each of the different sets or whatever they're going to do. There's good things to do there.
That optimization will always require that you occupy a value space that is not used in order to represent
you have an empty slot.
Options.
In the land of H2O, I needed to have a not available data type, data value among terabytes of data for individual cells. Mm-hmm. And I needed a bit pattern that was not used by any other value in those cells.
Yeah.
So I had to find the empty hole, and then I could reclaim it for use, meaning, no, there's no value here.
Yeah.
Same.
Yeah.
That's a good answer. We'd love Java to have used it. Fine. And now Mark's not here. Damn it, not the locks. From my experience, apparently not Mark's. The locks are rarely the bottleneck. And that's because people tend to jump on them early and over-engineer. They recognize it. It's easy to spot. It's easy to profile and say, oops, I'm hung up on a lock. And so, yes, if the lock is the bottleneck, you need to re-engineer things. And yes, that's a complicated job. And no, I'm not talking about it here. For my practice, I talk to people who've already fixed their locks. And that's not their bottleneck. They got lost in the over-allocation problem because there's no easy profiling point that says, you're out of memory bandwidth. Hardware counters, if you know which ones to look at, these other tells of high volume GC cycles that are reporting huge memory bandwidth being consumed through. But it's not as obvious as I clicked the profile button in IntelliJ and up popped this one big red bar that says, here's your problem. That didn't happen, right? Okay. And now I get into clarity, which is a lot of these things in my head go to clarity. And this is where I have performance versus clarity as a thing. And most of the performance work I do starts with understanding the whole of the problem. And then I get into things of what I'm doing about it, like removing duplicate work or just avoiding the work altogether. And really just trying to solve the heart of the matter, whatever the heart of the matter is. And that's why understanding is just key to performance work. And so I have a bunch of these best practices that I'm running into that just fly in the face of clarity for me. So super thin layers, zillions of super thin layers. Each layer is best practices correctly done, easy in isolation, and in bulk, you have terrible brain soup. Layer calls layer calls layers calls layer calls layer calls layer, and you just lose what the hell trying to get accomplished here. Getters and setters, making a jungle of function calls. And there are real function calls that do real things. They either change important state or where your time and energy go. There's some secret key thing in the one function call, and surrounding it is 100 getters and setters that do junk, that do nothing. And you can't find the real guy for the sea of junk function calls. Builders building builders, that's an easy one. We already had that discussion. I've in fact replaced one-liners in the existing code base where there was a builder making, and set the fields and then making an object, and they had a constructor right there that took the same objects, the same fields, the same values directly, gave the object directly. It was literally a one line, one name change to get the fucking new allocation. And why did you have a builder there in the first place? This fucking 3-field object had a builder pattern. Like, no. Okay, pushback time. Right, getters and setters. Hey, flexibility, I can override getters and setters, and maybe I want to do that. And in practice, you didn't do that. And you rarely needed that flex anyhow. I looked, and of the hundreds of getters and setters, at most one got overridden. Just ludicrous counts there. And every function call hides the intent of the program. right? So I can peek through 10 calls pretty easy, and hundreds of calls. I'm trying to sort through which ones, and then I'm up to here I'm up to thousands of calls, and there's no way my brain can keep what is cheap and what is expensive. Every time I come to a call, it may hint that it's a getter. I can't tell. Not all of them are. I have to peek through, and that just removes clarity. It makes it hard to understand the program. So I say, save the function calls for times when they do something important and get rid of getters and setters and sort of these options with parens everywhere as another, it's a function call. What's it do? Well, maybe it's an optional and it's just doing a null check under the hood, and maybe it's not. And now I have to go look. And yes, there are custom optional things in the code base I'm working on right now that aren't called optional. So I can't just tell by saying it's the word optional. That's a piece of crap, but I can read it, know what it does. No, I don't know what it does. Fine. Final fields. Final works, does what it says right on the tin. Make the final fields public and walk away. Use some discipline when writing to public non-finals. And this gets into private by default, which gets into like modern IDEs and all. I had to pop open a whole lot of classes in the existing project because the API didn't handle my case. And no one's in Oracle when they go right to API. There's no perfect API. There's no point in locking it down. Stop playing the no peeking at my internals game because you don't know what the future use cases look like. Fine. All right, enough kind of whining here. Here, rule of thumbs have a getter set when the caller is in a different repro than the callee.
If I can't do a transactional update to change all the callers and all the callees at the same time.
Right. Yeah, and that's fair enough. I'm not in that zone. Yes.
But often people are like, this is the edge of the module or this is the edge of the library. And it's like, yeah, but it all lives in the same Git repo. Like, just you can update all the callers and callees in one transactional event.
Like, right. And I am partly suffering because one of the repos I'm building over the Ethereum Besu code base, it maybe imagines this scenario, but in practice, no one's bothering to override, except and only for me, in my case, to just pop open the private fields. I make a subclass whose sole purpose is to have public getters and setters so I can get at the fucking fields. It's just like, oh, come on, guys.
Did you have to fork Ethereum for that?
Hashgraph did. They added new features. So Hashgraph changed the concurrency model. The consensus model. The consensus model for Hashgraph is Byzantine. Was asynchronous Byzantine. Like literally, there's no there's no leaders, there's no chief, and as long as no more than a third of the people are robust liars, then you'll get to consensus. Right? That's the whole point of Byzantine. It doesn't matter who's a liar, and it doesn't matter how many you have. Up to some fraction of the people can't be. If 90% of the people all agree that this is the truth, that's the truth. Now, are they the liars or the truth tellers? Well, history says it got written by the winners. and if you go back later, maybe things were a little more, a little more marginal. But
yes,
that's history.
Consensus and science are different games.
Yes. In this game, it's as long as 2/3 of the people are fair, you will reach consensus. You don't care who is unfair. And you don't care how slow somebody is or how out of whack they are, as long as 2/3 of the people will get back to you in a timely fashion. So they have a better consensus algorithm in place. That's already an important piece of extra stuff. Like you can't be dependent upon who holds the machine in question, sitting in my data center. So therefore I can change history behind your back, or I can prioritize my transactions over your transactions is one of the key ones. And on these big exchanges, the exchange says, in what order these transactions actually get applied.
So you do have the power to get rid of a bunch of these getters and setters across that boundary.
And then, yes, so going back to the actual problem here, I have worked way around some of them, and there were lots. And why were there in the first place is always bugs me. Levo, I do private methods all the time, Levo. Not necessarily private fields. I have private fields as well, but I typically have if they're final, I typically make them public. And if they're private fields, it's because I am intending to change the API and I don't give you a getter and a setter for that private field. I give you The easy one is, say I have a hash table and I'm changing the implementation. I'm going to tell you what the implementation is. But I have a size call. And you call size get count things in hash table. In some implementations, that size field is a plain field. And a getter, the size is actually a getter. But I'm actually giving you size, not a getter on the field. And some implementations of a hash table, say a concurrent one, size is not well defined, and there's some horrible thing that happens for size under the hood. But the API is you get a size field. Sometimes the size happens to be a getter. Here I'm talking about getters. They're just
so private by default is only for the getters and setters.
I'm sorry, say it again.
So you're saying don't use private by default on getters and setters and
don't have getters and setters by default, which you got by default because you went private by default. Go public by default. Private if you know you're going to change things, in which case you shouldn't have getters and setters. If you're private, you should instead have the API pieces like size on a hash table.
So the second
particular size call may happen to resemble a getter.
The second I read this slide, I thought this was meant in general for like don't have too many private data and too private functions.
Okay, so I don't have a good wording here. Private by default starts out for fields. Private fields by default. Instead, think about, do I really need to be private? And in particular, if I can be final, I can just be public and you can't touch me. So what the hell? Why not let you do it? Okay.
Because that'll make Smalltalk sad, where you can only send objects a message.
I know. I'm letting Smalltalk be sad. Sorry, Smalltalk. Smalltalk's not here for a reason. I think one of the reasons is it's just too slow. Maybe not. Maybe Smalltalk's the right world and we'll get there eventually. I don't know. Hotspot started out as a rework of the Smalltalk codebase. That was the first go around. Came from the Craig Chambers group doing self-compiler, not Smalltalk. Rewrite of Smalltalk into self, and then self ported over to Hotspot, to Java. Okay. Easy one, I hope. Exceptions. They should be exceptional. Some people do this right. Some people, I think, the current code base in particular does this wrong. Exceptions should represent an actual failure, a real bug, a fault, a panic, something bad. So should you catch and rethrow that? I claim never. You don't use exceptions for things like file not found, or a contract's going to fail because it ran out of gas, or it ran out of money. I transacted you $1 billion worth of Bitcoin for $1 billion worth of US dollars, but you didn't have $1 billion to trade, so that contract fails, right? So these things are the normal cases. There's a state machine that says the contract's idle, it's in process, it's running, it's completed, it's failed, it's succeeded, whatever. It's just part of the state machine. It's not an exception. Don't use an exception for that case. Here is an example I pulled out recently where somebody said the pointer was not null. And then they used a requires not null, and the JVM tested for null and threw a null pointer exception, which then this guy caught the null pointer exception and returned a null out of it. And I'm like, oh my fucking God, you cannot be kidding me. So, I replaced it with the obvious check for null and do the right thing. But why were you trying to catch a null pointer? Why did you declare a thing a not null when it could be null? So I yanked a couple of those too. They declared not null by default, and actually it's a normal case. It can be null. Fine. All right, next problem with catch clause is that they're rarely tested thoroughly. Sometimes they are, many times they're not. Not this project. I've seen plenty of times where people wrote a catch because they knew that something could be thrown here, and they didn't know what to do about it, and they didn't know what to do about it. So why the hell were they catching it? So they tried to do something, but they didn't test, and they couldn't actually solve the problem at their level, so they had no chance of solving the problem. And instead, they created a new one because they threw a different crash, and you could read by inspection of the code that were this clause ever called, it would immediately throw again with a different unrelated bug, and now you can't find the original cause. And you shouldn't have caught it anyhow because you can't handle the problem. The problem is catching when you cannot solve the problem. Let somebody else solve it. So get a little philosophical here. The concept here is that servers should be the only ones that catch code. and only at the top level, and only allow forward progress in the face of a bug that instead of panic and rebooting. So when I say server here, obviously a web server takes a transaction, but something breaks in the server, not in the nature of the transaction. It's not somebody did a database injection attack or whatever. Something broke in your server where you threw some kind of a crash, but you think you can handle the next web request, so you should catch and try again. Test handlers, test harnesses totally fall in this category. You expect tests to fail and crash in weird, bizarre ways, and you want to go fire off the next test. So you're going to catch and go again. Fine. Anyone who's doing, online transactions, everybody in the, Bitcoiny world, but there's a lot of folks that have online transactions, they should catch and go again in an effort to not have the system go down. But understand that the fact that you had an exception means that you are sick. Something is broken.
Yeah, so
and you're hoping that you have contained the breakage. And your sort of best hope that you're still alive, garbage collection cleans up the crap, you didn't partially commit some state that you didn't complete commit on, and therefore it's in broken state. You're not in that zone. You think the server is good to go, and so you're not just falling over and dying. But you had a bug. You should file a bug report and fix your bugs. Okay, Aaron, you were saying something.
Yeah, the place where I tend to see exceptions caught and rethrown is where someone thinks that they can fix up the state and then discovers that the state is too corrupted for them.
Right.
So they're like, oh, I have this thing that catches the problem and will retry, but if I try 3 times and it fails 3 times, then I'm going to rethrow it up. Or I'm going to blow away the thing and empty this cache and then try the request again.
Right, yeah.
And it fails again, even though I blew away that cache, and now I'm going to rethrow it back up because it's like, at my level of scope, I was unable to solve the problem.
Right. What I end up getting then is this corrupted stack trace, and I'm trying to root cause the original fail. And that your catch and retry attempt didn't actually fix it, didn't help solve the root problem at all, or the guy trying to debug and diagnose the root problem. So catching and rethrowing is always non-local control flow. It's always harder to reason about. Please, please, please give me the unadulterated stack trace. Fine. Okay, now I'm going to hack not null, and I'll go back to chat. There's a bunch of people saying stuff in chat. Yeah, loggers. A lot of failures I get out of the catch and rethrow guy is the guy logs in the in between, and something else fails, and he rethrows, and I get partially logged fractions of a exception, and I get them by the thousands, like ludicrous counts of them, and they're all broken. Whereas if you had one fail and you just took it at the top and you dumped that one and then you went again, I'd have the full stack trace and I wouldn't have thousands of partial stack traces. All right, never mind. Okay, not null, out everywhere. In this particular code base, everything is annotated not null. Everything just ludicrously counts. And they just clutter up the definite declarations. You can't hardly read the code for the not nulls in your face. But in any case, the JVM is going to check the null pointer exception. And you'll get the null pointer exception when you would otherwise, if you accidentally passed the null in the wrong place. That is, you'll get it where it's required, not where you've declared that you think it should be available. And the requires not null is another version of the same thing. It's a more utterly useless thing, the same issue. You're going to get the NPE anyhow. And go fix your bugs, right? But for the particular code base I'm working on now, if you just assume not null, almost all things are not null all the time. Just assume it, unless it's obviously being checked for null, or maybe the name hints that you might have a null here. Your code would be so much easier to read. And my number of bugs saved by the not null annotation, having the IDE tell me, hey, wait a second, this says not null. Did you really want to return a null here? I'll count that as 5 minutes over 5 months of savings time. It's like these NPEs that you get in these projects like this, they're really easy to diagnose and debug. There's not a hard problem, but the ability to read and understand the code is a hard problem. And having the not nulls just obliterate the code, blind you in a sea of them, does not help understanding at all. But the number, like I said, the number of bugs they actually save, tiny, tiny, tiny. Finals on arguments. Again, same. This is new in this project. Every fucking argument local gets a final keyword. JVM knows it's final or not. Every IDE on the planet knows it's final or not. My Emacs from 40 years ago tells me it's final or not at a glance, at a touch. I rarely see people update function arguments anyhow. What the hell do you need final in the code? Like, it's not adding any clarity. Certainly it has nothing performance. It's not adding any clarity either. Don't bother. Okay, and then that's it. And I'll go down the chat line here. Oh, this is one of several. There's several good talks, Matt, about these. All should go in the doc about how to handle exceptions. And exceptions are exceptional versus exceptions are just an error control flow.
I kind of like this perspective that this is in a situation that you would be canceling. Like if it was a transaction, you would be canceling this transaction and unwinding the entire stack of operations.
Right.
Because you cannot possibly proceed with that transaction.
So if the transaction's getting unwound and you're going to crawl the stack and unwind a nested series of them, you almost surely need interesting unwind logic all the way up. And almost surely then you want to do that programmatically, not by trying to catch and unwind and catch and unwind. You want to return, the nested transaction returns a, I failed, and the next guy up says, oops, let me clean up my stuff, and then I fail. And you roll that up gracefully as opposed to trying to catch and throw at every layer. Yeah. Guys, I would say Joe Beerbaum has a great talk on exceptions and exception mindsets. Fine. And then, yeah, Levo allocations. Loggers typically over allocate. Like the obvious logger fail is logger.log of if exception compute giant ass string. If weird case compute giant ass string, else whatever. And the string gets computed for the logger, even though the logger never logs because you're not in the error state. The logger has log warnings, log errors, log info. You're at the wrong level. You're not going to log. You don't want to log, but you did the string concatenation, which was the expensive part. And then deep underneath, the logger says, oh, it's a warning, and I'm at the error log only level, so I'll throw the string away. But you built the concatenated string, and you paid the cost for the logging. Fine. Right?
Yeah, so definitely always check your verbosity first, and then check, okay, am I going to log this?
But that's not the normal logging pattern that shows up in certainly in Java, but I've seen this plenty in C as well. And that's because the logger has internally his level, but the guy calling the logger just says, log me of warning level, blah, 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 and log me of whatever, and then too late, you already paid the cost because you computed the arguments before you called in the logger who does the warning check.
There's two ways to handle that. One is to pass like a Lambda function.
Yeah, right. So then you can get passing a Lambda function into your logger. And now it becomes just butt ugly to read. And I'm not saying there's not a solve here. It is commonly the case that people do not solve it in an efficient way. And the act of logging requires, it turns out to be allocating furiously.
So you're saying Lisp was right, and you should have a special type of function that's a macro that does not evaluate its arguments until...
Yes, that's not Java, though. But you could go there and see. You could have macros. And there are macro languages you could do this, yeah. You want delayed argument execution. Yep.
Right, but I often find I want way less from the macro system than most macros give me. I just want the ability to say, hey, for everything that's in my args, give me a lambda instead of the arg. So I only evaluate it if I feel like it.
In AA, I added syntax that you could make any argument lazy, and the and or logical Boolean guys are function calls that take their
and the function definer gets to
lazy.
Set that, not the function caller.
Yeah. I'm sorry, say again?
The function definer gets to decide, not the function caller, whether an arg is lazy.
Yes. And then the parser will ask the question. The parser has to resolve the call to know whether he should thunk it or not. So it does require me to have a careful step resolution. This only works if I can resolve your function pointer to it's going to be at parse time.
Certainly is useful if I want to do short circuiting argument things that only evaluate certain arguments if
Right, which would work for logging and anyone who wants to have a syntactically obvious thing that has short circuit argument on. Yep.
And your dead code elimination can see through that to not check for correctness of types of
Yeah.
things that are
That's
not
AA special.
just like it's an if.
Yeah. Right. You as long as the parser can parse it, he then put in the thunk and set it as an argument, the thunk as an argument. And then the type checker is coming along afterwards and saying, it's dead. I'm not going to look.
So there are
I
definitely
don't.
patterns I've seen that would be cleaner in that world. This feels to me a little bit like it conflicts with your thesis of this talk of here's this little bit of magic where now any developer who's calling a function
Yep.
doesn't actually know whether that got evaluated or not.
And I don't know. I haven't coded AA in anger, so I don't know how that one pans out. You're correct.
Like
I
I
did it
really
'cause I
like this
could.
feature, but it is counter to the thesis of this talk.
Yeah. Yes, it is.
I don't think I have an opinion, or I kind of don't like this idea, but someone once said that you do want to spend all that extra time building up the strings and all that because, um, assuming you're a server, but it also applies to games, this specific person said, you don't want, when things start failing, you don't want the CPU to go crazy. So if it's already spending the time to process all the strings, you have a reasonable expectations of how slow the CPU will be once things start failing.
You're talking real-time computations. Under all circumstances, you must be able to do X, including if logging is on or off. So the act of turning on logging had better not prevent you from doing X ops a second. I'm flying my drone and I need to do X many, aerodynamic updates a second. And some condition hits, so I turn on logging, and now I better still do X updates a second, or laws of physics says this drone's coming down. Yeah. So a solution to that, and this is totally done in the hard real-time world, is log all the time, do all these things the most expensive way all the time, because I can't tell in the worst case scenario. And to the extent of there have been devices, tools, utilities, whatever, where they just have no cache on the CPU. So everything's a cache miss, 100%. And then they get guaranteed slow, guaranteed behavior.
There's also structured logging that you can use where you log structs instead of like text, and then you deserialize it when you're trying to read the logs through like a special log reader application.
I'm definitely an evangelist for structured logging. I've seen that in large production systems, and it's a huge win to log 8 bytes that is nano time as opposed to string,
Yeah, I've done that totally.
I was very shocked in 2020 when Twitter did their big audit of like Intel called us and told us they wouldn't sell us any CPUs in 2020. So we had this kind of panic moment of, okay, what do we do if we can't buy any more CPUs for several months? And we did our audit, and it turns out the singest, brightest, hottest spot where we were spending ridiculous amounts of CPU was calculating leap years. Because every single log line started with a ISO timestamp. So I had to know how many leap years have there been since 1970 and how many leap seconds have there been since 1970. And we recalculated the number of leap years and leap seconds since 1970 on every log line across the entire organization.
It's always good to compile first because you never know.
If you log Avero structs instead of logging JSON, that's now just write this 8-byte nano time. It is much faster. So I used to tell people, don't format the string. You have to do it in the call to log. Because if you format it before you call log, then if it doesn't actually have logging on, you waste the energy anyway.
You paid the cost.
And then I realized you needed to push it down later and say, even if you are logging, you should log a struct. And I'm now of the opinion the only time that you should be doing the string formatting for a log call is after the search has completed in the logs viewing tool, and you've already done your search over the logs, over the binary data.
At the time you're
then do the string format.
Yeah. Logs are typically write only, read never. So you shouldn't do any extra work to making the log presentable at the time you're writing it. When you read it, Yeah, okay. Now you clean it up.
Our servers are logging a Vero that they then throw at logging infrastructure that batches up a whole bunch of logs from the servers and then changes them to a columnar format and writes Parquet out as the actual
Oh,
thing.
nice. Okay.
And
Yeah, when
you
I was doing
want your
bulk,
logs to be a columnar format where you can do column skipping over the columns you don't care about. Like,
yeah,
why should the logs be strings? Like,
yeah, there, yeah, right. Logging
anyway,
is
that's
never
my
good.
evangelism for structured logging and columnar stores for your log data.
I'm 100% on the same page.
I also like as the motivation what Intel processor trace does, because that's pretty much the only way to do this. It's basically tracing your processor and put it on a cycle per cycle basis. There is a lot of cycles in a multi-gigahertz CPU. So the problem is that if perf has to save this data to disk, CPU can execute branches much faster than the disk can keep up.
Right. Yeah.
So if your trace format is inefficient, you're just gonna have data loss. That's it.
So this is a fun war story from Azul. We had so many cores that we had a mode where we would take one L2 cluster of 8 CPUs, feed their traces to a second L2 cluster of CPUs. The second cluster would compress and then pipe it to the third cluster on the 3 clusters of 8 24-core chip, who would then do the I/O after it was all compressed. And we could keep up with one cluster of 8 CPUs at running whatever megahertz with the riding the fast disk out. So we could get these pretty beefy things, but we started by compressing at CPU speed on the die. Out of that came quite a few multi-billion, I don't know if it was trillion, many large billion line traces.
This reminds me of a time where my personal SSH server got denial of service and I couldn't figure out why I couldn't log in. As it turns out, basically because the SSH server was exposed to the public internet, right? There were a bunch of people trying to log into the server and failing, hopefully. And there were bots just like hitting this with so many login requests.
That it was
And
enough to DOS you.
I couldn't figure out why the SSH server couldn't handle the volume of traffic that was going in, because I'm like, okay, someone logs in the wrong password, you just fail. The reason it was so slow was because it was logging the failures into a database, and it was the disk
logging into a database even.
Or well, not it was like a list, a log list. Like I had fail to ban.
Logging. Yeah.
Yeah, and it was like it was the fact that it was trying to log all the failures of like login attempts.
Well, how many attacks a second were you taking?
It was just that it was logging too much, honestly. Okay. I don't know exactly
I ran
what the
a web server
is, but
for a while, public-facing web server, and there would be attacks periodically. They would come in million a second for no more than a few minutes.
So it was specific because I had this plugin called fail to ban, which was configured to like keep track of like failed logins and check okay.
Fail to ban can get a long enough ban list where checking the ban list takes more time than checking that the password was wrong in the first place. Because it's disk I/O as opposed to just password hash.
Right. I didn't ever hit that one. I rapidly logged everything, but I did columnar compressed storage logging because that was what I was doing at the time anyhow. So I never ran out of bandwidth. Like the Comcast line to my house wasn't fat enough for them to overrun the server. And then it turned out that I rapidly had like 90% coming from Belarus. So, I was running in Java. I was running the full TCP stack manually in Java on purpose so that I could now cut them off. So I would read the IP headers of the incoming TCP packets, declare it Belarus, record some interesting info, and cut the service, except I attempted to cause the most possible grief by claiming I had opened a TCP connection at their end, and I just threw it away on my end. And so they would have to time out on their end before discovering that they weren't actually having a connection. Except unless they're a script kiddie who's just throwing you baked packets that claim to be TCP and a probe without actually trying to run the full TCP protocol, which is what they were doing as well. So we were playing dick games with each other back and forth.
So in your talk, you talk about exceptions being exceptional.
Yeah.
Usually the way I've seen that accomplished is by returning some kind of result object rather than throwing an exception.
Right.
This leads to if result.ok, result.payload all over your code everywhere.
Yeah.
That
I don't have a
feels
great
like a pattern that you would
right.
dislike from what I've seen in the rest of the talk.
Right. So in the land of Java, I don't have a good answer. In Cameron's ecstasy, he explicitly manages that, and he's hoping that down the road the JIT will actually use two registers, one for the Boolean it worked, it failed, and the other for the result, which is either typed as a good thing if it's success or the bad error if it's a fail.
So the very nature of returning from a function has a status code, HTTP.
Yeah, right. And in other domains, I almost always can get away with returning a null or a thing for success or fail. And if I'm using integer ops, then you have one set aside
I see.
integer.
So you're avoiding the result object by using a null for didn't work.
Yeah, and that's not very informative. If it didn't work, I have to know why it didn't work. In the cases where it didn't work, was complicated, and I had to do something, then I get into the stuck pattern where I'll often tell the caller a structure that I've allocated, and he's going to fill in the pass or fail, and on the fail, he fills in the complicated fail. So there's no allocation from the caller, but the API is more complicated. I don't like it, but it's what Java does conveniently here.
So I worked in a Rust code base for a while, and we never threw any kind of exceptions. We always returned result objects.
Yeah.
And the number of times you would get these frustrating broken result objects where you're like,
really?
Okay, I called this thing and I got a result object that's got the string in it, and the string says didn't work.
Right. Oh, yeah. Well, that just same as my Boolean.
And it's okay, but if this had been a stack trace, I could have said what function called what function called what function.
I still allow for stack traces in my mental model. They just represent shit hit the fan, and I am not solving it here.
Right. So what we ended up doing was in our results error type, we had a field called error. And frequently we would have these things that's like, I called this thing, and if it was an error, make a result error that says, I am here. And then we would return that. And we build this stack trace. You just have this moment where it's like,
built a stack trace.
We ended up with a lot of code in our code base that was implementing stack traces so we could know where the error happened and which code it flowed through. And it's like, why are we writing stack trace?
Stack traces are very convenient and should be written by a system. I'll agree.
And it should be consistent. If it's written by the system, then they all kind of look the same. If it's every individual developer in every function, and if one person decided that they were not going to wrap the error, then you just had a missing level in your stack trace because they decided not to wrap the error.
My personal opinion is people should just write exception-safe code and then use exceptions, and then everything's good. It's like the whole.
This is the land of Java. The problem is that they're using too many exceptions. There is a sweet spot somewhere. I claim exceptions are good in some cases and not in others, and you need to land on the sweet spot.
I feel like anytime you're returning like nested errors, exception. If you have a specific operation that can only discretely fail as doesn't have sub operations, that's a good case for an error code.
Right. Now that sounds good. The other piece of that one is I claim the exceptions should be exceptional, and then you should only catch it once and never rethrow. And if you're catching, it's because you believe you can completely solve the problem. If you cannot solve the problem, you should not be catching.
I mean, I catch it and then I attach a tag to the exception and be like, okay.
Yeah, and then I thought I could be useful to. You are allowed to catch and add tags, but you're not allowed to say I tried and I failed. I'm rethrowing. If you catch and add tags, the system's going to rethrow and continue on, and you'll get a full unadulterated stack trace with some annotations stuck off to the side.
Yes, that's usually what I want. I want the catch and rethrow, the catch, annotate, and rethrow.
Yeah, and instead of
be part of the same stack trace.
Yeah, I don't want to say catch and rethrow because that gives the mindset that I'm going to stop the rethrow process and then restart it. Instead, I want to say I'm going to
You
add
want
some
catch and
data to the
release.
exception. And you're not allowed to stop the exception. It's happening.
Well, also in C++, for example, there's the concept of logic error versus runtime error. And the idea is like, okay, I got a logic error. This is an actual error. Keep throwing it up, right? Like this is a hard error, you know. Runtime error is like, okay, network timed out. You could say, okay, I'm going to only catch runtime errors and then retry. And then if you fail to retry, you rethrow your runtime error. But if you get a logic error, you just let that propagate up.
Yes.
So you can say,
Yeah.
okay, these are
Java
potentially
has
retryable.
That's that Joseph Bobaugh.
Java has that. The things I too often see that we avoid the throws in the signature too many times. I've almost never seen a throws in the signature.
Yeah, this is the problem of checked exceptions in Java. It wasn't a good idea. In terms of the volume you'd have to write to maintain that we all have exceptions. That's why everyone turns into a runtime, so they don't have to keep typing all the fucking different exceptions all the way up the food chain.
Yeah.
You shouldn't be catching and renaming the exception. You shouldn't have to put it in the damn side of the call. Just assume it could throw. The only person who's going to catch it knows how to handle it.
But the one that if you annotate the function that with throws, doesn't the one that uses it must always catch?
No, the one who uses it can either catch or
declare.
claim he's not, in which case it throws through him.
Yeah, okay.
And so he has to get annotated because he now throws. And on and on and on.
Yeah.
Round and
Yeah,
round
he has to annotate that he throws also, and that should propagate the chain all to the top.
It's a giant verbosity hit in your code base.
I'm not fan of exceptions. Really.
I always feel like I'm doing I'm throwing exceptions poorly, so I just have asserts, and my asserts just like prints and exits, which I also hate. But I have to pick one of them for error handling, so I end up picking panics. But I really hate
the Java version's got this one right. If you didn't bother to catch, that assert would throw, exit the JVM, which is what you're doing, and give you the full stack trace. The key issues, you get the full unadulterated stack trace.
Yeah. An assertion error should kill the process and give you a stack trace.
And give you the stack trace. Yeah. And I'm actually of the opinion it should give you all the local variables, all the things that are easy to get. I can totally give you every local variable at the time the stack trace happens as well.
That's security scary.
Yeah, I know.
And
now
then
your
someone
logs carry,
catches it and puts it
but
onto
if
the
you're
web.
handing me a stack trace and it's got every function call mentioned along the way, what kind of security hole is that? That seems pretty big already.
Yeah, I guess part of the answer is you should just say the ability to read a stack trace requires deploy permissions for whatever that service is.
The ability to write a stack trace is not sorry. You should catch, if you're worried about the stack trace, now you catch at the point at which you would catch to recover, and you log it in your private format. And then I'll take the private format from my clients later and unpack it then.
That's one of our policy things that sounds like a super simple rule, but ends up being more complicated than you think it is.
Being real pain in the neck. Yeah, maybe it is.
The permission to redeploy a service and change the running code.
Yeah.
The permission to attach a debugger to a service and examine its memory.
Yeah.
The permission to look at the heap dumps from a service.
Yeah.
And the permission to see the stack traces that come out of the service are all supposed to be identical. You either get all of them or none of them, and they are one atomic thing.
Oh, I see. This is like
either you have the right to examine process memory for that service, or you do not. And if you do, you should be able to attach debuggers and get heap dumps and see stack traces and redeploy the service. And if you can't, then
right. I'm thinking about IBM ABEND, abort, abnormal ending core dumps. You got a wad of bytes. If you also had the debug and the compiler and the process data along with it, you could interpret the dump, which the author of the dump code, the right guy who wrote the code did, and the guy who had the crash in hand did not. So it was de facto encoded via obfuscation. Fine. Pattern matching home. Try catch. Oh, God. Oh, geez.
It's a very funny post. The title matches the intent even sillier C++, where you can use try and scratch to implement basically pattern matching in C++.
It's like, why?
To be a joke, of course. Basically, you can have expression node, then you can implement things like addition node that does the addition, and you can basically evaluate the value by throwing.
Yes.
The same for the expression. So you can find like an expression parser or like an interpreter that's just gonna be doing pattern matching by catching the exceptions and looking whether it's an addition node or integer node.
Okay, okay.
So we have pattern matching in C++.
Obfuscated C contest here. I love this. Try, throw. Catch this, catch that. Return.
It's literally pattern matching.
Oh God, expert throw under of oh God. Yeah, I see how it works. I'm just like, okay, fine. That's because C++ has catches with exceptions. Java has catch on exceptions, but there you can instance of tree.
So have you ever seen tree-shaped stack traces?
Oh, I generated them. But
I was thinking about my case where I have this rule that says I'm going to try the thing three times, and if it fails, then I'm going to go up the tree.
So to answer your question in Levos,
yeah.
same time, in H2O, where I did this distributed scale out, blah, 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 distributed system, somebody would throw almost always every replicated process, every thread would throw the same thing for the same reason at the same time, just spread out over a big cluster. Hundreds of copies of the identical exception, except for recursive calls down the fork join list, would come back at me. So I would gather them up based on the tail that was unique, fold up all the stacks in the middle, and have an exception return object. And then at the cluster, at the node level, that went back, and then the fork join process did a reduction on exception things, just the same as did everything else, and folded them up. And you would be sitting in your IntelliJ, and I would give you the stack trace, and he would totally jump to a sample failed guy, and his stack trace would report on this thread, on this process, on this machine, and here's the IO jump to the next machine, and it went through the cluster all the way back to the top call, and you could sit in IntelliJ and walk that stack trace, and he would take you back to the fork join process that launched, or down a chosen, randomly chosen path of the millions of options. And I also would get these 90% with this one guy and 10% with this other stack trace and 1% with this third or fourth. And I gathered them all because I didn't know which one's going to be the hot one and gave you the winning loser or the winning stack trace of most common failure. But you could go look at these other traces and they're always flavors of the same thing. We all had some agreeable if whatever failed deep enough in the algorithm, but if you went the else path in the algorithm, you failed also for the same reason, but in a different path or whatever. But yeah, I did. And those were essentially in my head, tree-shaped exceptions on a distributed system. Is that what you're at? You had a different thing, or was that the same thing, Aaron?
I think it's the same thing. I was just doing it over time instead of space I tried the thing and I have this rule that says you can try 3 times before you've genuinely failed.
Gotcha. Yep.
What I should do when I hit that point in the stack trace is it should branch and have 3 paths and say, here's the way the first try failed, and here's the way the second try failed, and here's the way the third try failed. And that should it should only throw 1 exception, not 3 exceptions, because the retry failed 3 times.
Yeah, so you return an exception object that has this annotated exception that has this tree on it. Yeah. I had the same thing where I had the replicated for the fork join things. I counted and I gave you a count in the stack. The stack trace itself was fixed, but the side data said, and here you went fork join recursively 17 times, and then it was statistically because I merged multiple of these guys and they all fork joined the same place. And so you can see the bell curve of after some time of forking along, we all then tailed off to the same thing and died.
So the typical pattern where I saw this, where you're getting these failures back, that the retry actually helps in some way, is that you're doing a gRPC call across the network and you've set some timeout that says, hey, go call this service, and if it doesn't get back to me within 10 milliseconds, then I assume that it has failed. If my time to first byte is less than 10 milliseconds, kill the connection, make the request again, you'll get routed to a different server or whatever.
Yeah, the H2O model is a little different. I assumed you were going to be live and you'd come back, but maybe you didn't hear me because the network was congested, so I'll say it again.
So if I want to drive down the stack and up the... I guess I'll phrase it like this. If you had a language where you wanted to build in that gRPC feature of, I have set a deadline, If this, I'm making this function call right now. If this function call does not come back to me in 1 millisecond, kill it and just hand me an exception that says deadline exceeded.
Yeah.
How would you get that to go up and down your entire stack? And how would you get something like the JVM to actually somewhat cheaply implement
Oh.
having deadlines on functions all over the place where you have to
And all
keep
functions all over the
checking
place.
the.
Yeah. So I was heading down that path with ecstasy, and then I ran out of money and got a paying job. Um, yeah.
Because I really do kind of want deadlines on a lot of functions and say,
No,
hey,
right.
if this thing's not returning in 10 milliseconds, that is a bug that I want to nag a developer about.
So in the land of ecstasy, you would do that by changing the nature of the function call to be a service call. And it would still look like a function call, but you have chosen a different type. And then you get you can add a delay, overhead, whatever. Service has to return, and if it fails, the service will return, but with this error code saying, "Hey, service call failed."
And now I can run my entire test suite. And if my test suite starts failing because I'm throwing deadline exceeded errors.
Yeah.
I mean, one of the things that's been my question for a long time is I want to allocate time budgets to different things that are happening in my stack. I know I want to respond to the user in 150 milliseconds. There's a bunch of things that need to happen there. You want to give them each some amount of that 150 millisecond budget.
Right. Sure.
I've seen this.
I've never found good tooling for that.
I've seen this in structured concurrency. I'm not sure if you have run across this, but it's kind of about handling cancellation of nested events well. And then what you can do is to have composable algorithm like when any with specific semantics so that you cancel all other operations when one completes and you propagate cancellation throughout the entire stack. And then what you can do is to have when any deadline pass operation, comma, whatever operation you want to do. And at this point, you have now imposed a budget, knows that it's structured, so it means it's going to propagate down the entire stack. And if any operations along that stack contributes in aggregation to exceeding the budget, everything gets cancelled.
So
It's
H2O
kind of made for the use case like this, I think.
H2O's concurrency was very similar to this, and I totally could do this kind of a thing in there. There was the notion of I'm looking for things to complete. I have a pile of them to complete. The general rules, I wanted them all to complete, but there are specifically rules that said when any completes, like I'm doing going out across the network to a key value store, the surety key value store, I ask all the possible key homes. Some subset of the big cluster has replicas of the key. Ask all the key homes. Give me a copy of the key. First one back, throw the rest away. And he would cancel and propagate cancels and all that. Yeah, this could be done. I like the H2O concurrency model, not just the fork join that was built over the underlying one, but the underlying one worked really nicely. It wasn't so nice language-like. You have a nice little languagey thing there. So you're writing Java code and you had to write the boilerplate directly, carefully, and you did to this particular coding style you had to write, and there was no compiler support to help you, so that kind of sucked. On the other hand, when you wrote it the correct way, you had all these kind of options. They would all just work, including timeouts like this. And
yeah, I think I would ultimately want something that was very H2O-like and very Erlang-like with the supervisor trees.
Right.
It kind of sounds like this should be part of like some kind of async library where you just say make all these RPC calls, and if any fail, or I mean, if any exceed, then throw them, cancel them all, and throw an exception.
You want all of them or one of them is the kind of the obvious things. I actually had a know that this key got replicated to sufficient count. So I would send out to 4 replicas, but when the first 2 had completed, I would say, good enough. The other 2 will complete later. That's great, but I have enough redundancy that I'm willing to charge forward from here.
Yeah.
So
but deadlines let you do interesting things. One of the things we noticed was we had a few services that had set their deadlines to 60 seconds. They tended to respond in 6 milliseconds.
Right.
The standard deviation was another 6 milliseconds.
Ah, okay.
So it rarely ever took more than 30 or 40 milliseconds to respond,
Right.
but it had a deadline that was at 60 seconds.
Right.
So if they had a performance regression, they would never see it in their statistics.
Yes.
And just having internal tooling that would go to developer teams and make diffs and be like, hey, we noticed that you've got ridiculously higher headroom compared to what you're actually doing. Can we turn the dial
Yeah.
on your
Yeah.
gRPC to be a realistic representation of what you have so that if your service suddenly gets 20% slower,
Yeah.
you
You blow up on
notice?
testing and not when everyone else who relies on you being 6,
Right,
not
because
60.
everyone else evolves into depending on you being
Yeah.
at approximately a certain level of performance. And these people would be like, but we only promised them we would return within 60 seconds. And it's like,
Yeah.
by returning within 60 milliseconds, you
Yeah.
have implicitly promised you're doing better than 60 seconds.
Yeah. Yeah. You have to return something close to the limit that you're failing at on a regular basis to hurt the people who depend, and then they'll fix their problem. Or they'll complain at you and make you dial your dial. Yes, but if you don't say anything, yes. What's the
And
what's the Hiram's law? Everyone depends on you being fast because you have been. Well, even though you don't promise it, yeah. You didn't promise this behavior, but you delivered it for year on end, so we all just assume.
right, that's one of those things. It's this very valuable stability metric that I didn't realize of like, warning, you are drastically exceeding the quality of your promises.
Yeah,
That is a risk.
that's an unusual. Yeah, I wouldn't have. Yeah, that's not a usual one for me to go. Yeah,
Um, But that's just what's been making me think recently about how you would performantly implement in a JVM ecosystem a more function level. There's a deadline on this function, and if it ever takes longer than this to respond, you get deadline exceeded. And
you're
now I
not.
can start to rely upon certain function calls not taking more than certain amounts of time.
You're
Why
not.
shouldn't it be like some kind of framework or async lib or anything?
I assume it would live in an async lib.
But it's not. It's not a JVM per se issue. This is an implementation over JVM who probably can
Right,
give
but
you the
you
right
have to
guarantees you need
think
to
about the
build it.
JVM somewhat, or
You have to build it as a library. You can do
you
like an
know,
H2O and clean
even just
this.
calling get time of day in some functions can double the cost of the function.
Nanotime, not nanotime. Actually, nanotime's pretty cheap too these days. Nanotime and current time millies are both cheap. Get time
On
of day.
Linux, it's basically built in.
I guess that's sort of my question. If I write something that wraps a function in um, take the current time millis, call the function. If the function returns in more than the current time millis, don't propagate up the return value, just
Well,
throw the deadline exceeded exception.
no, you want to throw the deadline when the time runs out. Now you have to have a timer. Timers are expensive, not getting current time millies. So
Maybe. So one thing, the dumbest way to do it, and the thing that you can start with is you exceeded your time. It took a long time.
yeah,
But what you actually care about is the aggregate. So even though that particular call was really bad because you didn't kill it on time, you at least got an exception that got thrown and percolated to the top and got logged,
okay,
and
but
you got
wait.
an
If
app
you're not,
crash.
if the call completes, it's just slow at it. That's called profiling. You just profile a sucker.
Right. I
You're
want to
saying I want
turn
to.
a slow return into a app crash.
You want it to actually start crashing on you. Yeah, okay. In the land of debugging slow pause times for Azul JVMs, we eventually got to we logged it as this time to save point was exceeded, and we gathered the logs and declared the bugs and hunted them down. But we let
Is
the JVM
that a feature
proceed.
that's in the JVM to say, hey, every time you get to a save point?
We would
I don't know this
somebody
term, time
yeah,
save point.
yeah, the time to save point was important. This is like a low pause time garbage collector. So garbage collector guys say, I'm starting a save point. I came to a save point. How long did it take? Okay, well, if it took more than X, like what the fuck? This is bad. So go diagnose, right? Well, you first have to collect, I took too long. And then you can get to the, under some circumstances, I would get too long. And then you get to, I added more annotations so when I start a save point, I marched some extra profiling bits so I can figure out who the hell was slow. Some thread was slow. Why was that thread slow? Oh, he's caught in IO. But why, she save point already. Why does that matter? Oh, I failed to mark him as caught in IO, so I waited IO completed, blah, 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 whatever it's going to be. There was always an excuse for somebody to be slow. You had to go figure it out. You had to treat it like a bug and engineer for it. That was the right answer.
Yes, that's the place I'm trying to get to is finding something that I can put in my code that will say, at this point, if this is slower than this speed, that is a bug that we need to go through all of our normal bug processes to solve.
Right. You have to treat it like a bug. Now you have to catch it. You don't have to have it throw right now. You can just say function call, whatever. I have a timered function with an error. I took a lambda and internally he times the thing and then he puts your bug report somewhere and then it proceeds correctly. So you can just wrap it with a less than 10 millis and you get the reports, right? You get the filter reports. But that's essentially profiling. Most profilers don't report it that way. But if you have a random stack trace profiler, you just gather the fucking profile, the stack traces, you could compute that.
Also, if you throw and you're going to restart your process, which means you won't know if it's a transient thing or if it's a load thing, or if you're running out of memory, you're just going, is this, you're throwing all that information away. Just log it.
Right.
Time log. And then the bug thing's part of your process, not, your business process, not part of your system.
Yep. Yeah, H2O would take timeouts as a thing that needed a retry in the system, but not as a halt and catch fire. All right, it's now noon. I'm hungry in hell. Oh, more things show up in the thing.
It's interesting that you mentioned the error approach because in Java's implementation, they do actually use the exception for this. So they have like timeout exception.
That's just Java throwing exceptions
propagated or cancels the operation. It's by no means universal. In C++, you do not use actually exceptions for this, at least not necessarily. So that surprised me a bit. But maybe in Java it fits better.
So I did with H2O, we also did the custom joiners. I was reading your title here. I didn't read the whole thing. There's definitely custom joiners. And that was a big part of actually how things worked. You were required to, button click exception, yes. You're required to take every fork you did and throw the fork's future piece on a to be joined. And if you drop it on the floor, that was considered a bug. And then in fact, that would hang the system pretty directly. You threw it on a to be joined, and that to be joined could collect millions or billions a second of those. That was easy. And it would otherwise gather them up and you could join after you had forked millions of times or whatever. But you always had to join. And that kept the bounded time. That told you how long. In the case of the fork join, we actually collected the statistics on how long each of the forks took and crossed the wire collections and stuff. There was a bunch of timing info gathered on the.
So I interrupted earlier when you were saying you could set a timer if you wanted to actually kill the process that took a long time to respond.
Yeah, I didn't do that.
In JVM, like there's no way to just say in some save point.
When all is best understood.
Boy, you didn't come across, Matt. No sound. All right.
Like you could imagine a timer that does something crazy like erase the function or something that's gonna make you throw a weird exception. But
you want an exception on the timeout for a function, which I heard you say.
Yeah, it's been running too long. I hit a save point.
Yeah.
I realized that I've exceeded my budget. So I stop.
Yeah.
I don't know if you can do that in a library.
And in the land of what I was doing with H2O, if you did that, that would be a death throw. That would be a clear loser. So Aaron, I think the right answer there is to say
So I set the timer on a separate thread. If the timer goes off before being canceled,
yeah,
then I throw at my thread a kill.
yeah,
This will then cause a I've been killed exception to percolate up the stack.
yeah,
The place where my timer is should now catch the I've been killed
yeah, wrong thread.
exception. Hmm?
Wrong thread. The guy who's going to have the function that might get aborted
Yeah.
has to catch. The guy who throws is always on another thread because that's how timers work. So the catcher is the same guy who calls the loser. So the catcher up here says, this call may fail. H2O all the time. I'm doing an IO call to a remote guy. I
Right.
may fail, right? So I put myself on the fork join blocker list. Things might happen, whatever. And a timer was set on this communication protocol back and forth that I expected a response. The timer in another thread boinked somebody over here. And in my case, I didn't have to do it this way. But in your case, you're saying I have some thread, I have some function, who the fuck knows what it does. I smash it with an exception. The caller will see the exception come at him. He has to catch it. I caught a timeout exception. Some thread underneath me, some function underneath me has timed out and reports a failure. And now I do whatever cleanup I'm going to do.
Right. So the person who's killing your thread, can he throw an arbitrary exception into your thread, or he has to throw a like thread death exception into
No, he
your
can throw
thread?
anything fucking think he wants. This is the
So
beauty
any
of paying.
thread can throw any exception into any other thread at any time, and it will show up at the next save point?
Yep. He can throw a null pointer exception in totally null free code at any point.
And as long as nobody explicitly catches that exception, it'll just percolate up all the
Well,
way
it
to the
does
top.
exactly what you expect an exception to do. At the next save point, that exception appears and percolates to the next catch.
But I thought Java had
Even if
safe
it's a null
exceptions
pointer
where you
exception
could
in code.
know what a function threw.
I'm sorry?
I thought Java had exception safety where you could know what exceptions a thread could throw.
Thread.death or thread.whatever throw exception is deprecated and supported forever and a day. Any exception can be thrown at any other thread at any time. Any exception.
Okay.
And
so I guess that's my answer is I set the timers and I just have a wrapper function around my function call that
right.
sets the timer and calls the timing thread and says, this is my thread ID.
Yeah, and I'll catch.
If I don't call you back with a cancel before this amount of time happens, then throw me a deadline exceeded exception and it'll percolate up.
Yeah, Ben's comment is correct. Checked exceptions are only a Java C thing. It has nothing to do with the JVM.
Okay. I guess this is actually much more possible. No, this is good. This is much more possible than I thought it was, and looks like it can be entirely done in a library that's just a deadline.
Do I promote this? No. Will the JVM now some future date? Maybe the JVM decides it won't, but I bet you same as all the like thread whatever the unsafe things I use all the time. Now I get complaints that protobuf uses the same unsafe bits that I use for non-blocking Hashmap. And is Oracle going to take away Google's protobuf serialization library? I don't think so. But the reason they're there is because there's no replacement. And what the fuck are you doing, Oracle, that you would try to deprecate this thing with no replacement? Hey, we used atomic add and increment, blah, 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 for the replacements for the unsafe. No, you didn't. You added these things, but they are not replacements. They do not have the same semantics. They don't have the same overhead.
Your mental model for AA is also that any thread can throw any exception at any time.
I didn't go down how to handle with AA and threads.
Okay.
That one I'll have to think about. I certainly don't like the thought of one thread throws an exception at another. There has to be some other way to deal with.
There's got to be a solution to I set a timer.
Yeah, right. So this is
or there was an interrupt that came across the net. Like arbitrary interrupting of one thread from another is important.
Well, I want to make sure that that's important. That one seems obnoxious. I solved it in the JVM. I know how to solve it in general. Okay. Solve it in the sense of the low level it doesn't break things. The sandbox didn't break. Now, having said that, is this like what you really want to? You pay a cost for that, by the way. Well, that's the cost is you have safe point checks. So actually, it's not the only real cost. The language level cost, the Java C level cost is that fucking who knows what semantics mean. I wrote some line of code. It says I compute Mandelbrot's in a tight loop. There's no nulls. There's no anything checks. I'm just doing +1 in a tight loop. This loop throws. What? This loop throws a Aaron Goldman's good idea exception. What the hell? I mean, it's not declared. You can't find it. You can't see anywhere. You can't catch it. You're not catching what the hell. But that's what the current semantics are. And when you throw Ben, the JVM will clean up the locks. He will not break the sandbox on memory.
Oh, no. What I'm saying is one thread should only be able to break another thread out of a lock with a lock exception. Otherwise,
I
end
got a
up.
web server. The web server takes a request. The request runs some crappy code I got. The crappy code just never ends. It's a denial of service attack. He's trying to fork bomb me.
Then you're just going to kill the entire thread. The problem.
I see what you're saying. You can kill a thread. You just don't throw an exception. And thread.death, by the way, is one of these things that the intention was you can't catch it, but you can.
Yeah.
You can't catch it, and it was supposed to kill the thread.
Either you're going to kill the thread entirely, in which case you've got a memory semantic where you're not going to get broken invalid states in maps and stuff.
Yeah.
Or you're killing it because it's taking a long time.
Yeah. You can't make any of those guarantees about memory safety on the other thread in any shared memory. This is what Ecstasy does with their sandboxing model. A thread runs on objects that are only thread local to it, so that when you kill it randomly, you can, in fact, just reap the thread in a stack and get everything back with no breakage. But that's a requirement of a more complicated model than the Java one. Java certainly would allow you to crush a random thread with maps half baked, half completed, whatever. Non-blocking hash map would be okay. Because the non-blocking piece means that it can be interrupted at any point and it is a correct map in all cases. So you can blow out a thread in the middle of a non-blocking hash map without corrupting the map. Not so of every map, though. Like in particular, if you're mid-resize from an old size to a new size map, and you crush a thread that's doing the copy from the old to the new, that will break most thread implementations. I think it'll break concurrent hash map, and it will not break non-blocking hash map. Randomly, one of the fun reasons to go there. All right, we're well past time. This talk got exciting. This was fun. Okay. As far as I know, I'm on next week, and the week after, I'm probably at my company retreat meeting, whatever. So I'm on next week, but not maybe the week after. All right, folks, it's been fun. And see people in a week. Bye-bye.
Bye.